So guys, let's see here. We have a types of discontinuities also. It is not like that we have some permanent discontinuities. Some are removable. We can remove the discontinuity of the function. Okay. If we have limit x tends to a, f of x necessarily exists, but is either not equal to f of a or f of a is not defined. In such case, we can remove the discontinuity. So it is possible therefore to redefine a function in such a manner that limit x tends to f of x is equal to f of a and makes the function continuous. How is it possible? Probably you'll be confused. So I will start with some example. Let's take the example. So I'm taking one function f of x, or I'll take g of x. The function is sin x by x. So if I'll take x is equal to 0, the function is not defined. Basically, we can say that it is not defined. G of x is not defined at x is equal to 0. So there no chance that we should talk about the function at x is equal to 0, that it is continuous or not. But we can. How is it possible? We know that from the limit, if I'm taking the limit x tends to 0 for this g of x, it means limit x tends to 0, sine of x by x is 1. We know the limit of this function. So here we got the limit. Now, so limit, we know sine of x by x, limit sine of x tends to 0, sine of x by x is 1. And that is our main point. We can start with that. Now I can redefine my function as sine of x by x, where x is not equal to 0, and 1 when x is equal to 0, and at continuous at x is equal to 0 when we are using the limit for this function, limit x tends to 0. So for this case, we can extend the function like this way. When we are using limit here, definitely it will be 1. So it means my function is 1. Okay, and left hand limit for this function and right hand limit definitely will be same only. If you will check left hand limit for this function and right hand limit, it will gonna give you same. And my function is 1 at x is equal to 0. So yes, we can say that. So this is the extended part of the problem which we have taken to make this function as continuous at x is equal to 0. So this is the way by which we can make any function as, not any function, which is extendable. It is possible for some function which can be extended at that particular limit, and we can find out the continuity of a function. So here it was discontinuous at x is equal to 0, but by taking this function as in such a manner, so we can make this function as continuous at x is equal to 0, because here we can prove left hand limit and right hand limit, and here my function is 1 at my f of x is equal to 0. So my function is 1 at that point. So yes, we can make the function as continuous. So this is my function is continuous. So this is called as removable discontinuity. Means we remove the discontinuity. Now my function is continuous. Okay.